Okay, so we have the following circuit here. We have to solve for I using the superposition theorem. So let's start by turning off these two, and we'll replace it with the closed wire. So it'll be 8 ohms here, 4 ohms here, 4 ohms here. This will be closed, 3 ohms here, and we'll add the current source here. And then there's I moving in this direction, and then the ground node. And since this whole region is connected to the ground node, it'll be 0 volts. Now let's write directions of current. Let's call this one I1, I2, I3, and this one will be VA, this one will be VB. So for node VA, it's I1 plus I plus I2. I1, it's from VA to 0, so VA minus 0 all over 4 ohms, plus I, which is VA minus 0 all over 3 ohms, plus I2, which is VA minus VB all over 4. Adding these ones all up, we get 0.8333 VB. And then this one, let's bring it to the other side, so it'll be equal to 0.8333 VA equals 0.25 VB. Divide both sides with this value, we get VA is equal to 0.3 VB. Now for node VB, it's I2 plus this value, this was 3 amps, so plus 3 equals I3. So I2 will be VA minus VB all over 4 plus 3 equals I3, which is VB minus 0 all over 8. So VA, let's substitute 0.3 VB minus VB all over 4 plus 3 equals VB over 8. Now let's take care of VB. So let's bring this to the other side. So it'll be 1 over 8 plus 0.7 over 4. So 3 equals 0.3 VB. VB will be equal to 10. Now we can use this to solve for I. I is equal to VA over 8. And VA is equal to 0.3. Sorry, I is equal to VA over 3. And VA is equal to 0.3 VB. And VB is 10. So we'll put in 10 here. So I will be 0.3 times 10 divided by 3. So I is 1. So this I, however, does not take into account these two. So we'll call this I prime. So I prime is equal to 1. Now let's do this whole circuit again, but turn another source on and turn off another one. So we'll turn this one off. So we replace it with an open wire. So this pretty much means there's no current passing to this section. So it's pretty much useless. Now we'll turn on the 24 volt. Alright, and let's do a mesh equation. So we'll have I1 here, and then we'll have I here. So for mesh I, it's 4I minus I1 plus 3I. So FOIL everything in, it's 4I minus 4I1 plus 3I, collect like terms. So 7I equals 4I, 1. And I is equal to 4 over 7, I1. Now for mesh I1, it's 24 plus 8I1 plus 4I1 plus 4 I1 minus I. So 24 plus 8I1 plus 4I1 plus 4I1 minus 4I. Collect like terms. So 24 is plus 16I1 minus 4I. Now let's isolate for I1. So I1 will be equal to 4I minus 24 over 16. So we'll plug this into here. So I will be equal to 4 over 7, 4I minus 24 over 16. So let's start breaking this down more. So 4 divided by 16, that's 0.25. I minus 24 divided by 16, that's 1.5. And then times everything by 4 over 7. So that's 0.1428 I minus 1.5 times 4 over 7. That's minus 0.85714. Now let's bring this to the other side. So 1 minus 0.1428. We get 0.85714. I is equal to minus 0.85714. That means I is equal to minus 1. But this I is not the same as this I because we did not take into account this one and this one. So right now we'll leave this one as I double prime minus 1. Now let's do the circuit one more time. What we're going to do now, let me just redraw this all over again. So what we're going to do now is turn this one and this one off, but keep this one on. So it'll be looking like this. So 8, 4, 3, 4, and 12. And I is moving in this direction. We can see these two are in series, so it'll be 12. And then these two are in parallel. So 1 over 12 plus 1 over 4 and 1 over that answer. This gives us 3 here. So now we can find I. So we know V is equal to I1 times R. V is 12. I1 times 3 plus 3. Oh, sorry, not I1, just I. Sorry, I should not say I1. So I is 2. And this I will be I triple prime. Now if we add all of these up, we'll get our real I value. So 1 minus 1 plus 2, that gives us 0 plus 2. So 2, this is our final answer.